Hi everyone, I want to talk about a subject today that you're going to see pretty early in your chemistry course, and for me this was maybe one of the only subjects that made me think, I hate this course, and this is memorizing your list of polyatomic ions. It's unavoidable. There's going to be some unpleasantness if you don't like memorizing, which I don't know anyone who does, because it's almost like learning a foreign language. You just got to learn some of the words. So we speak with atoms and ions and polyatomic ions, big groups of atoms that we give special names to sometimes. So you got to learn this stuff. And some of it is not necessarily systematic. It's actually, to me, this was harder than in organic chemistry when you had to learn how to name all the compounds, because that at least had a system. This is, some random guy in 1700 decided to call something one thing, and there's a little bit of a system. But I'm here to reduce a little bit some of the memorization you're going to have to do, and that's specifically related to the charge of a polyatomic ion. So my trick is going to be to show you how to determine whether the charge on a polyatomic ion is even or odd. Now you might ask, how does that help me? I need to know the charge. I don't need to know whether it's even or odd. But it turns out that there's two, maybe three or four, if you're really unlucky, polyatomic ions that are not either -1 or -2. I'll put them down right here. NH4 plus, sorry, new pen. NH4 plus, and then PO4 -3. This is ammonium. This is phosphate. So memorize those two. You're going to have to memorize their charges as well. They're just outliers. Everything else, pretty much, you can, find if you get another one that's not -1 or -2, put it on this list. But everything else pretty much is going to be -1 or -2. And if you know whether something's even, that something is even, then you know it's the -2. If you know it's odd, then you know it's a -1. Okay. So what you do is, the way you start with this is you look at your periodic table, which you will almost always have available to you. I don't remember any chemistry class I've ever had where I didn't have the periodic table even on an exam. But look at your table and you can figure out whether an atom is in an even row or an odd row. So the even rows are 1, 3, 5, 7. So you're going to have so in terms of atoms that are probably most likely found in polyatomic ions, you're going to have hydrogen. I'm going to make a list of the odds here. Okay, you're going to have hydrogen. You're usually not going to have lithium or sodium, so hydrogen is the only one from column 1. I don't remember. Let's see. I think boron and aluminum. Those aren't usually in your polyatomic ions, so we could ignore column 3. I know, again, you can look at your table. If you find an ion with aluminum in it, you can figure out that it's an odd. I'm just going to list the most common ones, though. Then we got nitrogen, and we got phosphorus, and we got fluorine, chlorine. I've never really seen a lot of ions with bromine or iodine, but those are in your odds. Common evens that you're going to see, okay, very most important is going to be oxygen. Sulfur is in there. Carbon, obvious, again, probably not going to see silicon, but there it is just in case. Those are your most common evens you're going to see. Okay, and now we're going to go to the math principle that odd plus odd is even plus even is even, and odd plus even is odd. I have even reduced that to a simpler principle. I can't even handle memorizing 3 things, which is that every time you add an odd, you're going to change the oddness or the evenness of something. Evens don't change anything. So if you start with an odd and you add an even, you'll stay odd. If you start with an odd, you add an odd, you'll go to even. If you start with an even, you add an even, you're going to stay even. So whatever you want for that, we'll go through a few right now, how this would work. So you figure out, basically, do I have an odd number of odds or an even number of odds? And an even number of odds would also be 0. So start out with NO3. Okay, what's the charge? Well, nitrogen we see as an odd. We got one of those. And then evens, I just ignore evens. Like I said, evens don't change the odd or even character of something. So ignore the oxygen. So I have an odd number of odds. I have one odd. So therefore, the charge on NO3 is odd. And like I said, since we only have -1 and -2 as options, we know it's -1. I'm going to write 1. I don't usually write 1. That's a terrible one. I don't usually write 1. I just write minus when it's -1 or +1. All right, so let's go to something else now. HPO4. Okay, so what do we got? Well, we got one hydrogen, that's an odd. We got one phosphorus, that's another odd, and that's all. So we have two odds. That means we have an even number of odds. That means that we are even. So this is sure enough -2. All right. How about H2PO4? Well, you got two of these, two hydrogens, one phosphorus. Those are both odds. So we got three odds. That's an odd number of odds. So we're back to -1. Okay. Let's try another. SO4. Okay. Well, how many odds do we have? Well, we don't have any odds. We have sulfur, which is an even, and we have oxygen, which is an even. So therefore, our charge on this is going to be an even charge, and it's -2. Okay, ClO3. Okay, chlorine, that's an odd. That's all we got. One odd, an odd number of odds, so it's minus. Okay. And notice, we could even do it with, I don't want to confuse you here, but we could do it with NH4 too. This quote-unquote works. The only way it doesn't work is, so how many odds do we have here? Well, we got one odd here, and we got 4 odds here. So that's 5 odds. We have an odd number of odds, so our charge is odd. Well, let's look. Oh, how about that? +1 is an odd number, but again, I want you to separately memorize NH4 because it's an odd number, but it's not -1. Okay, I want you to think odd number, odd polyatomic ion means -1 generally. Okay, so hopefully this is a useful trick for you. If you have any questions, feel free to ask me in the comments. I'll try to respond. I would say that you should just go through your list of polyatomic ions that you have to memorize. Go through this exercise, see if it works. Convince yourself that it does. And then this will be one less thing that you have to worry about when you're taking a test.